Hello everyone, welcome to Basics e-Learning. In lesson number 8 video of network analysis, I am going to explain step-by-step procedure to solve the problems on superposition theorem. In my channel, I have already uploaded videos on signals and systems, Fourier analysis, Z transforms and a lot of numericals also given. I am providing the link of which in the description box. Also, students who need online classes can contact us through the mail ID that is given in the description box. The first problem is use the superposition theorem to calculate the current in branch PQ of the circuit shown. Let us see the solution. Follow the solution carefully here. So, according to superposition theorem, the number of sources, each source has to be considered independently. So, in the given circuit, I have two voltage sources. So, we have to consider each source separately and the other source we have to replace it with internal impedance. So, step 1, first consider 4.2 volts source. This source we will consider. So considering 4.2 volts source and then replacing the other source with its internal impedance. So the other source is voltage source of 3.5 volts and there is no internal impedance given. So we have to short circuit this 3.5 volts. So let us redraw the circuit like step 1 you write it considering 4.2 volt source. Then the circuit will look like this. I am just redrawing the given circuit with short circuiting the 3.5 volts source. So the circuit looks like this. So this is 4.2 volts, 2 ohms, 1 ohm, 3 ohm and this I have short circuited. This is 2 ohm. This is PQ. So we need to find out the current that is flowing through 3 ohm resistor. So first problem I have chosen a simple one. So let us find out the current that is flowing in this 3 ohm resistor because of 4.2 volts voltage source. So if you see here this 3 ohm and 2 ohm are in parallel, then all the three will come in series, right? So that is equivalent resistance I am finding, total resistance, right? Or else you can do in another way also. Let us draw. First find out the equivalent resistance of 3 and 2. 3 in parallel 2, that will be 3 into 2, 6 divided by 3 plus 2, 5, that is 1.2 ohm, right? So as we need the current in 3 ohm resistor, that is the total current. We have to first find out the total current. Then the total impedance R equivalent will be what? 2 ohms plus 1.2 ohm plus 1 ohm. That is totally you will be getting 4.2 ohm, right? So current I total is V by R, that is 4.2 divided by 4.2, which is nothing but 1 ampere. So the current that is coming out from this 4.2 volt source is 1 ampere. So this 1 ampere is divided between this 3 ohm and 2 ohm. We need the current that is flowing in 3 ohm. So the current in 3 ohm resistor, I will use just the current division rule. Total current, that is 1, into opposite resistance, that is 2, divided by sum of the resistances 2 plus 3, right? So 2 divided by 5, that will get it as 0.4 ampere. So the current that is flowing in this branch PQ or in the 3 ohm resistor is 0.4 ampere because of 4.2 volts. Now we will repeat the same procedure with considering 3.5 volt source and replacing this 4.2 volt source with internal impedance, that is short circuiting 4.2 volts and using 3.5 volts. What is the current that is flowing through PQ? That we will do now. Now let us redraw the circuit by short circuiting 4.5 volts and considering 3.5 volts, that is step 2. So I'll just redraw the circuit with the changes. So the circuit looks like this. I just replaced this with short circuit and just redrawing. So this is 4.2 volt source, that is short circuited. The second source is 3.5 volts. Here this is 2 ohm, this is 3 ohm, this is 2 ohm again, and this is 1 ohm. So PQ. Now because of this 3.5 volt source, what is the current that is flowing in this 3 ohm, that we have to find out. So if you see here, this 2 ohm and 1 ohm are in series. So totally 3, right? So 3 in parallel with this 3 ohm. So 3 into 3 divided by 3 plus 3, right? So this 2 ohm and 2. I am just considering the total equivalent resistance here. 2 plus 1, right? That is equal to 3 in parallel with again 3, right? So that is in series with your total resistance, that is 2 ohm, right? So that you can write it. So this is nothing but 3 into 3 divided by 3 plus 3, which is nothing but 1.5 ohm, right? So this circuit is now simply like this. You can draw. This is 3.5 volts. This is 2 ohm and this is 3. So total this you can write it down, right? The total current I is equal to V by R. So total resistance you find out 1.5, sorry, this is 1.5, right? So 1.5 plus 2 is 3 ohm. R equivalent is 1.5 plus 3 or 2 ohm also you add, that will be 3.5 ohm. So total current I total is equal to 3.5 by 3.5. Again you are getting it as 1 ampere. So the current that is coming from this source is 1 ampere. This 1 ampere, because of this 1 ampere current, how much the current is flowing in 3 ohms, that we need, right? So if you see here, these two can be replaced with one resistance, that is nothing but 3 ohm. Here this is 3 ohm, this is 2 ohm, and here I have this 3.5 volts. So the current that is coming from here, that is 3.5 volt source, is 1 ampere. So the 1 ampere is divided between these two 3 ohm resistances, right? So obviously if the current is divided between two equal resistances, it will be half and half. So this 1 ampere is divided as 0.5 ampere and 0.5 ampere. So 0.5 ampere is going in upward direction here, if you see, right? So because of 3.5 volts voltage source, the current that is flowing in PQ branch is from Q to P, that is 0.5 ampere. But if you see it in the previous case, the current is flowing in the downward direction, 0.4, right? So now we have to add these two currents. According to superposition theorem, the current that is flowing in any branch because of multiple sources is equal to the sum of the currents that are activated by the independent sources acting independently, making the other source inactive, right? So sum, we have to add them up. So 0.4 is in downward direction plus 0.5 is in upward direction. So totally the current flowing is 0.1 ampere in upward direction. So because of these two sources, the current that is flowing in the branch PQ is nothing but 0.1 ampere and the direction is from Q to P. So like this you can mark. So this is how we can solve this problem. The second question I have chosen is little like bigger one, that it has 3 sources. Question is like this: apply superposition theorem to the network shown in the figure to find the voltage across the capacitor of reactance 20 ohm. So this one 20 ohm resistor, right? So you mark this one with some nodes PQ so that it will be easy. So if you consider the circuit, you have two current sources, J2 ampere and J1 ampere, and also you have a voltage source of 20 volts, right? And we have to find out the current through this PQ because of all the three sources using superposition theorem. So according to superposition theorem, if you are considering one source, the other two sources has to be replaced by their internal impedances. So now first, step 1, I'll consider this J2 ampere source. So I have to replace 20 volt source by short circuit and J1 ampere this current source with open circuit. So let us redraw that. That is, I'm considering only this J2 ampere. Then the circuit looks like this. You have an impedance and another impedance, right? This is capacitance, and then I'm just short circuiting. Then again this capacitor. So here you have an open circuit, so no need to draw this one. So let us mark, this is J5 ohm, J5 here also. This is minus J10, minus J5 ohm. Now we have to find out the current that is flowing through J20. This one is J20. Yeah, we have to find out the current that is flowing through this minus J20 because of this J2 ampere. Now if you see these two capacitors, that is minus J10 and minus J5 are in parallel. So total will be minus J20 into minus J5 divided by minus J20 minus J5. So that will be minus into minus plus, and J square is minus again, minus 100 divided by minus J25. That will be, you'll be getting minus J4 ohm. So replacing these two capacitances with a single capacitance, the circuit again looks like this. See here, right? So this is my J2 ampere, J5 ohm. Again here we have J5 ohm and minus J4 ohm. Now we have to apply the current division rule, as this is a current source itself. So this J2 ampere current is divided between these two branches, that is one is J5 and the other one is J5 and minus J4, that is these two are again in series. So again you can replace these two also with one branch, that is nothing but J1, right? Is J5 and minus J1, right? So then it looks like this. Let us call the current that is coming is I, and here let it be I1. So we need the current that is I1. So I1 is equal to total current, that is J2 into opposite resistance is J5 divided by sum of the resistances J5 plus J5 minus J4. So this will be, if you solve this, you will be getting it as J 1.67 ampere. Do it with your calculator, you will get it. So understand the concept, calculation part you just go and check. So the current that is flowing in this branch is J 1.67 ampere. So if you see here, the current that is coming here on J5 is J 1.67 ampere. So as we need the current that is flowing through in J minus J20, this current, this J 1.67 is divided between these two branches, that is minus J5 and minus J20. So again you do the current division rule here to find out the current in PQ branch, so that you write again. So as we are considering the first source, let us call this as I dash. Okay, so total current, again current division rule, total current J 1.67 into opposite to that is minus J5 divided by sum of the resistances minus J5 minus J20. So if you solve this, you will get J 0.33 ampere. So J 0.33 ampere in the downward direction. So the current that is flowing through PQ, that is minus J20 ohm, the capacitor, because of this current source is J 0.33 ampere. So let us repeat the procedure for the other two sources also. Now consider another source. So let us consider J1 ampere source and replace the other two sources with internal impedance. So this current source has to be open circuited, and the voltage source, this is 20 volts voltage source, has to be short circuited. Then the circuit looks like this. As I am opening this current source, no need to draw anything there. So the remaining circuit I am drawing like this. You have a current voltage source here. I just short circuiting, and then I have a current source here, right? So this is step 2. Okay. So this is J1 ampere minus J5 ohm minus J20 ohm, J5 ohm again, and J5 ohm. So we have to find out the current. Let us call this as I double dash because of the second source we are finding out. So we have to find out I double dash, that is the current that is flowing through minus J20 ohm because of J1 ampere. So if you observe, this is so simple now. You have this J5 and J5 are in series, right? So that will be J10. So this J10 ohm and this minus J5 are in parallel. What I'm doing is, as I have to find out the current in this branch, that is minus J20, I'll find out another branch. So all the remaining impedances, I'll make it as one branch. So that this J5 and J5 are in series, that is J10 in parallel with this minus J5. So that will be J10 in parallel with minus J5. J10 into minus J5 divided by J10 plus minus J5. So anyhow minus J5, right? So this will be minus J square is plus again, right? 50 divided by J5. So which is nothing but minus J10, right? 5, no? 10, right? So this will be looking like this. I have a capacitor of minus J20 and the other 3 are reduced to some impedance of minus J10 ohm. And I have this current source J1 ampere. Right now, I have to find out the current I double dash because of this J1 ampere. So just use the current division rule. So I double dash is total current is J1 into opposite resistance is minus J10 divided by sum of the resistances minus J10 plus minus J20. So this will be minus J square is again minus 1. So plus J10 divided by minus J30. So if you solve this you will get it as J.33 ampere. So if you see here, again the direction is also important. Again this is flowing from P to Q, right? So like in the previous case, again it is downward direction. So the current that is flowing through minus J20 ohm because of J1 ampere is J.33 ampere here. Now step 3. So considering the voltage source and replacing the two current sources with their internal impedances, that is open circuiting, the circuit looks like this. So I am just considering only the voltage source. So here I am drawing the voltage source and open circuiting the two current sources, both the sides. So this is J5, J5 and this is minus J10 and minus J5. So again this circuit is simple here. We have to find out the current, that is I triple dash, that is flowing through minus J20 ohm because of this 20 volts resistor. So for that we have to find out the equivalent circuit. So again these two are in series. So J5 and J5 are in series. J10 is in parallel with minus J5, right? And then whatever the required this one, right? So let us redraw. This is 20 volts and then I have the required impedance that I have is here minus J20 ohm, right? Or else you do one thing, this you just replace, right? J10 is in parallel with minus J20 first, right? So that is J10 into minus J20 divided by J10 plus minus J20. So that will be 20J. So this 20J is again in here. You will be getting it as this is 20J and then this is J5. That minus J5. You can draw as a capacitor or some impedance show, right? So now we have to find out the current that is flowing through. Anyhow, these two also you can replace it with single impedance. That is, the circuit looks like this. This is minus and plus single impedance. So these two are in series anyhow. So that will be J20 and minus J5, J15 ohm, right? This is 20 volts. Now find out the total current that is flowing through. Okay. So I is equal to V by R 20 divided by J 15. So that is you will be getting 1.33 J ampere, right? So this again you have to find out the direction also, right? Always the current is flowing from plus to minus, right? So now this current is the current that is coming from 20 volts is J 1.33, right? So this current, out of this current, how much current is flowing in minus J20 we have to find out. So if you see here, if you keep this minus J20 and replace everything, that you will be getting this as simply, this is 20 volt source, right? So if you replace this, what you are getting, J10 and this is J10 in parallel with minus J5, and then you have one capacitor minus J21, right? So if you do this calculation, I triple dash is total current is J 1.33 into, so the current is coming in this way, right? The opposite direction compared to the both, right? So let us take it as minus for that reason. Okay, as we need the current in downward direction, and the current here because of the source is flowing in the opposite way, so you take it minus, right? So J10 divided by J10 minus J20. So this J10 is nothing but this one. J10 is in parallel with minus J5, right? So that is nothing but J10. So this you are getting. So the current you are getting here is 1.33 ampere, right? So but the direction is different here, right? So the direction is in the opposite direction. So that is J 1.33 ampere you are getting here. So now combining all the currents that are flowing through PQ, because of J2 ampere it is downward direction, that is I dash. Then because of 20 ohms this is going in the upward direction, I triple dash. Then because of J1 ampere again in the downward direction, I double dash. So let us add all the currents. Total current is J 0.33 in the downward direction plus J 0.33 in the downward direction plus J 1.33 in the upward direction. So the total current here will be 0.67 ampere in the upward direction. So the question is to find out the voltage across this capacitance. So voltage across the capacitor is equal to current into the reactance minus J20, right? So that is you can write this is 0.67 J, right? So 0.67 J into minus J20. So this you will be getting it as 13.4 volts. So the total voltage that is across minus J20 ohm because of all the three sources is 13.4 volts you are getting. For more videos, please do like, share, subscribe to our channel. Let us know your suggestions and queries in the comment box. Thank you.